The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon on the East Coast and good morning on the West Coast. My name is Michael Meyer. You have dialed into the Department of Energy, Better Buildings Lighting and Electrical Research Team call. So hopefully that's what you were planning for. If not, and you're here for a welcome surprise, thank you for coming to a new topic. We're going to move on to the next slide and you'll see what our agenda is. So today we're going to present about the integrated lighting campaign. We are launching the integrated lighting campaign at the 2020 Better Building Summit, which we'll talk about a little more in the next slide. We also have a featured presenter from National Renewable Energy Laboratory, known as NREL, a colleague of ours named Kim Trenbath. She's going to present on plug loads and why they're important. And why the management of them is important. More importantly, I'll be discussing some lighting and HVAC integration, as well as some non-energy applications. We'll then touch base also on the IoT-Upgradeable Lighting Challenge. And then finally, we know that many people come to these phone calls to solicit feedback and information from staff members, from other companies. And so we always try to allow for that type of information. If we could go to the next slide. So at this point, we always like to pause and we're going to unmute all of the phone lines. This is where we like to ask for introductions. We always find it easiest to do best through time zones rather than guessing who people are. So if you find yourself located either in the Atlantic or the Eastern time zone where I'm located, if you could state your name as well as your organization and or title of in that organization. It's helpful for us for recording purposes as well as for your colleagues to know who else is on the phone. So I'll start off with, I'm Michael Meyer. I'm in Pacific Northwest National Laboratory, but I'm located in upstate New York. Other people in the Eastern or Atlantic time zones?
Michael, this is Doreen Minichia with DLC.
Hello, good morning, afternoon.
Good afternoon. In Boston.
Thank you.
Sort of.
This is Stuart Berjanski, also with the DLC, Technical Director, located in Pennsylvania.
Welcome, Stuart.
I'm Kathy Moretto. I'm with CBRE on the Wells Fargo Bank account team, and I'm located about 30 miles northwest of the city of Detroit in Michigan.
I always forget, I would miss that one every time. That's on the East Coast, or Eastern time zone. Thank you. Anyone else on the Eastern time zone? Okay, we now move into Central time zone. If you are located in the Central time zone, and you can state your organization name and where you're located, please. I'm scanning through the attendee list to see if I identify anybody in the Eastern or Central time zone readily available. And there are some people who've signed on that are unattentive at the moment, which is totally understood. Moving on, I guess we'll then move into the Mountain time zone. So if you are on and you can hear me, if you could, and you're located within the Mountain time zone, if you could state your name and your organization.
Hey, Michael, this is Kim Trenbath from NREL in Colorado.
Thanks, Kim.
Hey, Michael, this is Bennett Doherty from NREL.
Hello, Bennett.
And this is Robin Tuttle with NREL in Colorado.
Hello, Robin.
Hello.
Are there any other people located in the Mountain time zone? We do have more people on, but it does look like some people have self-selected to be muted, and I understand some people can be shy. We'll then move into the Pacific time zone. If you could acknowledge or announce if you're in the Pacific time zone, please.
This is Levin Knock with DLC.
Hello, thank you.
Linda Sandahl, PNNL.
This is Jingjing Liu from LBNL.
This is Felipe Leon with PNNL. I'm in Tri-Cities in Washington.
This is Sergio with PNNL. I'm in Tri-Cities as well with Felipe.
Okay, I think that's most everyone. As I said, there's a couple of people that are on that are quiet in the background, which is sometimes that's their choice and understood. So if we can move into the next slide. As I mentioned, the integrated lighting campaign will be kicking off at the Better. I'm sorry, the computer was telling me that you were all being muted again. I apologize. I was confused by what the computer was telling me. The Better Buildings Summit, this is something that has happened for about 8 to 10 years in person. Obviously, with as many travel restrictions and other events happening right now, it, like many other elements, has gone virtual. So it is still being held in June, but it is a virtual leadership symposium. The link is down here at the bottom where you can go to the betterbuildingsolutionscenter.energy.gov to sign up and register. One significant advantage of it being virtual is that that limits travel, and that may allow your organization to join because the cost, you don't have to pay for travel and those type of things. There are a number of great sessions ranging from water and operational changes. They also focus on the Better Building Challenge, where organizations have really wholesale changed their energy footprint and what they've done, and you'll learn from them. That's always informative, and a number of people I know often look forward to attending it. It will be sad this year that the actual tours will not be available because it'll be virtual instead, but I do think they'll figure out some other ways to solve that. And as is noted is on that slide, the event is free to attend, so the URL is at the bottom of the slide. So that's the Better Buildings Summit, which I said is where the integrated lighting campaign will officially kick off. Could we go to the next slide, please? But the remainder of the presentation is really going to focus on the integrated lighting campaign and why we're here and what it can do and the energy savings potential, and then we'll also touch base on the challenge. So this time I'm going to turn the presentation over to my colleague, Felipe Leon, who is leading up the integrated lighting challenge. Felipe? Hey, Felipe, you're on mute. Give me 1 second. We'll unmute you, Felipe. All right, can we step back one slide, Felipe, and hear that again?
Thanks a lot. Actually, let's go back one slide because again, I'm Felipe Leon, and I've been with the interior lighting campaign for about 4 years. And we are transitioning to the integrated lighting campaign. So I didn't want to just, jump right into the integrated lighting campaign without really giving a lot of props to everyone that has helped contribute. And certainly the people that have called into this L&E call have made great contributions and have even been recognized by this campaign. So I just want to give this slide as a summary of what we've done as an interior lighting campaign. We've documented 3.5 million luminaires. That's leading to about $84 million worth of savings each year for those organizations that transitioned. We've recognized, we provided 51 recognitions for exemplary performance and developed 10 case studies. And this program, just like the integrated lighting campaign will do, provided guidance and recognition in the early days of LED adoption. So we're just shifting the focus, but still taking the same approach and hopefully creating the same kind of benefit to the stakeholders. But all the information didn't just go away. you can see here that while we sunset this campaign, there is a toolkit that is available at the Better Building Solutions Center.energy.gov. And it's an interior lighting high efficiency solution toolkit. So you're able to go there, see a lot of the information about interior lighting and how you can upgrade that. So hopefully you'll visit that and see what information is in there. Next slide. So as Michael mentioned, the Integrated Lighting Campaign is launching. It is launching at the 2020 Summit. It is free to register. So we certainly encourage that. And what is the Integrated Lighting Campaign? So the campaign is really focusing on the benefits of integration. It's focusing on best practices, lessons from the field, the experiences, and more. And that's really what we're going to share some information about at the launch event. So it'll be an hour and a half to really provide a little bit of information about integration. It's going to provide some information about observations that building owners have had. And then the campaign itself will have a website. And that's really what brings a lot of value to people that are just interested in the technology like they were in interior lighting in the early days. So the website will provide resources. Those resources will include utility incentives and other incentives, information resources such as lab research that has been performed by either PNNL, NREL, LBNL. And then we also want to promote the use of innovative lighting sensors. So that's something that we're looking at right now. We know that occupancy sensors and daylight sensors are the norm when it comes to choosing something to control lighting, but there are many more opportunities. And Michael will touch a little bit on this when we get into IoT challenge. And then also we want to encourage that integration with other building systems. We're talking about HVAC and plug loads here for starters, but there's so much more that can help your building as well as your business to work better. The thing about HVAC and plug loads in particular is that you can get deeper energy savings. And for people, sometimes that's a very easy thing to quantify. The verdict is still out. There are still a lot of numbers and it can vary depending on the building, depending on how you use it. But there are savings opportunities that go beyond lighting by simply just taking that sensor data, integrating the systems, and now having that sensor data feed those systems. And then, of course, we want to document and recognize integration and innovation like we did in the interior lighting campaign. We provide a recognition for exemplary projects, and that's something we'll continue to do. So we certainly encourage you to sign up for the summit as well as to join us for that launch workshop, which is going to be on June 10th from 11 to 12. Next slide. So we'd like for you to join the campaign, and we'd also like for you to join now. And really, the campaign is made up of two key stakeholders. The participants are the building owners, the facility managers, those people that are actually taking these projects and putting them into their buildings and using that technology. So we absolutely want to hear from you. It's through our collaborative efforts, it's through the information that you provide, it's through case studies that we'll develop from your exemplary recognitions that will be able to inform others, other peer buildings about the information that you collected, the benefits that you've observed, and if quantified, how much value you put into that new information that you're getting from these sensors. Supporters are those utilities that are providing incentives, energy efficiency organizations that are doing research on this technology, manufacturers, ESCOs, and other organizations such as the DLC, which is a consortium of utilities that can join as supporters. So what are the benefits of joining now? First, we'd like to recognize you as an inaugural participant or supporter at the launch event. So we'd like to get your information so we can do that. You'd be listed on the campaign website as it launches. And then you'd also be eligible for limited technical assistance as a participant. Those that are just starting projects or considering integration in their buildings, it's not just for lighting, but also we've got a network of labs that might be able to help. For example, we have Dr. Kim Trenbath, who will talk about plug load and process and plug loads here shortly, as well as LBNL has a Beyond Widgets research that we've been doing. So we can always help connect if it goes beyond lighting as we expect. That integrated lighting campaign will go and encounter those kind of projects. And we also like to hear about your projects and have you apply for recognition. So you will stay in touch with the campaign, and you'll hear about the recognition categories, and you'd hear when recognition is opening up so that you can apply. And how would you sign up? It's simple. Just send a message to integratedlighting@pnnl.gov. We'll receive your email. We'll know your interest, and then we'll just ask for a little bit more information from you to complete your registration. Next slide, please. So why is it we're doing this? And I think that the rest of the presentation will go take it into this. Lighting already leverages sensors to save energy. We know about occupancy and daylight. But that sensor data can be used in other systems, building operations, plug loads, and HVAC. So we'll cover some of these in the next hour. But also there are new capabilities on the horizon. The Internet of Things sensors or devices may go beyond typical lighting sensors of what they do today. Lighting can become a platform for these sensors and devices and enable things such as having a Bluetooth mesh in your building. What would that be able to do for you? Some companies are already starting to use it, so we'll talk about that. And that brings the opportunity for non-energy benefit potential. And we know that when we talk about energy, that's one of the lower costs for business. We know that there are higher value propositions, for example, in building rent costs or people costs. If you can get higher productivity or if you can get savings from operations, that's something that can be a benefit here. Now, on the right, you'll see that there's a quantifying. We become very comfortable, and it's very easy to quantify the energy savings in lighting. But as we've gotten to these other systems, HVACs, or as we've gotten into non-energy benefits, it's become a little bit harder to really put a quantity, a value to this. So that's really what the campaign is about, is starting to compile and get that information so that we can make it more broadly available and get people to understand what the benefits are of doing that integration and starting to continue to encourage the integration of their building systems. Next slide. So to that end, I'd like to introduce Dr. Kim Trenbath. She is with the National Renewable Energy Lab, and she and her team are working on plug and process research, and she will be presenting to us on some of their findings. Kim?
Great. Thank you, Felipe. Can you hear me okay?
I can hear you.
Okay, great. Wonderful. Hi, everyone. Thank you, Felipe and Michael, for having me on the call. I really appreciate it. And hi, everybody. I'm Kim Trenbath. I work at the National Renewable Energy Laboratory in Golden, Colorado. I have a team of about 4 people that work with me on plug loads, plug and process loads. We lead a team called the BBA PPL Technology Research Team, similar to this lighting and electrical team. And as Felipe described, it's important to come here and talk a little bit about plug loads because this is one of the areas where we see integration with lighting. So next slide, please. Great, so plug and process load include plug-in and hardwired loads in a building that are not associated with HVAC, lighting, ventilation, and water heating, and other major equipment used for basic building operation. And so, for example, in an office building, this includes things like computers, monitors, printers, projectors, cell phones, and task lights, anything that you see here on this slide. And then process loads include equipment for commercial and industrial operations in the building shell, which includes vertical transportation like elevators and escalators. And then it can also include industrial washing machines that are used in hotels. Next slide, please. So this data comes from the EIA's Annual Energy Outlook of 2018, and plug and process loads is about 40% of whole building energy for US commercial buildings in 2017. And it's projected that that amount is going to increase to 49% in 2040. And the reason why is that plug loads have been historically difficult to control because of the diversity within the loads. You've got computers, you've got lamps like lighting that get plugged in. And then also the variability in how humans interact with the loads. They also can be made up of a bunch of different loads within the building, so they're decentralized. Next slide. So why integrate lighting and plug loads? So Felipe touched on this, and I think Michael's going to get into this a little bit more, but lighting controllers exist, and if you look at some rooms in a building, you've got your occupancy sensor to detect whether or not the light comes on. But why can't we do that with plug loads? Because plug loads are often used when people are actually in the room. So we can take advantage of some of these synergies with the two technologies. And there's technology that exists right now that integrate both of these loads, and Michael will talk a little bit about that a little later. So I think that integrating the plug loads with the lighting controls is one of the first steps to achieving coordinated control. Next slide, please. So how are plug loads controlled? So plug loads are metered. So the energy use is metered and controlled through things such as controlled receptacles, advanced power strips, plug load management systems, and then even settings on electronic devices such as sleep settings or low power settings. And then also you can control your plug loads by encouraging occupant behavior to be a certain way. So that's a non-technical solution. So this picture here on the left side includes a picture of a smart plug, which is part of a plug load management system. And the smart plugs are wireless meter and control devices that can measure and track and then control your plug-in equipment. And one of the metering capability is particularly helpful in helping you understand more about your building. Next slide. So when plug loads are controlled, we can see up to 30% and even up to 40% savings for individual pieces of equipment. And so this is about 7 to 10 energy savings for the entire building. So controls are worth investing in and looking into for your buildings. Next slide, please. Here's a slide that overviews a couple benefits from the plug load metering and control, and this includes energy savings, as I talked about before. That 30% is a significant amount. And then also using the metering capabilities, you can identify high energy consumers and especially find these during unoccupied times when you might not want the plug loads to be using the energy. And we can do this and use these smart plugs to disaggregate the load in your building. So figure out what types of devices are using the load and at what times. And then from that information, we can determine some conservation strategies that consider the occupant's needs. And then finally, another benefit is the future interoperability of building end uses. So Felipe touched on this a little bit earlier, but this is interoperability is not only integrating your systems, but it's also allowing one system to send signals and control another system. So this could be like having your building automation system provide controls to your plug load system. And so for greater building coordination, we are striving for interoperability of all these different systems. Next slide. So now I'm going to go into a quick scenario. This is a study we did for device level plug load disaggregation in an office building. And the office building was actually the office building that I work in. It's a zero energy building in Golden, Colorado. And it used these smart plug devices. Next slide. So we were trying to find a disaggregation profile. So just to see the load for all of these plug load devices in the building. And you could go and meter all these devices with the smart plugs, but we didn't have enough of those. So what we did is we used, next slide, please. We used an inventory approach and only metered a select number of those devices. So say we metered 9 computers instead of all 100 computers that might be plugged into the building. And then we used the inventory to scale up to figure out what the total load is. And one thing I want to note is that the building, it was built to be a zero energy building, so it had a plug load submeter on it. Next slide. Here are the raw metering results, and this is before we do any of the increase due to the inventory. So the black line that you see here is the load profile for the building, the plug load submeter on the building. And then the colored lines, the colored areas that you see at the bottom are load that we metered with these plug load devices. Next slide. And here is the way that we estimated the number of devices in the building. We developed an inventory and we figured out how much we wanted to multiply those average loads that we actually calculated with the smart plugs. We multiplied them by these numbers to get the overall load. And so next slide. So when we do that multiplication, you can see that the load now, the colored area, which is the load of all the devices in the building, is now almost up to the magnitude of the plug load submeter, but it's not there quite yet. So what we were able to find is we were able to pretty well capture the magnitude of the load, but we weren't able, not the magnitude, sorry, we were able to capture the shape of the load, but we were a little bit off on the magnitude. So that means that there's still some loads in that building that we weren't able to capture in our model. But this information tells you things that are useful. It can show you areas where there's energy use of devices that's wasted energy, times during unoccupied times where there's energy use that shouldn't be. It also shows you kind of your baseline energy use at night. And so if you want to try to reduce that, you can try to reduce some of those energy consumers that are on at night. And then in our building, one thing that you can see is that there's a peak around noontime. We know that this is from the microwaves peaking and some other, from the microwaves peaking, and that's not the case in all buildings. This building that we're in has a kitchen, but it would drastically be different if the building that you were in does not have kitchens, and so people would be going out to eat instead of staying in and making their lunches. So really the characteristics of the plug load shape really depends on the devices that are in that building. Next slide, please. So here is a graph of the average load profiles for select devices. Across the top, each column is a different day of the week, and it shows the average load, and then down the side, it is the average load for a different device. And I want to bring your attention to the bottom, the AV controller. One thing that we were able to do is identify that energy use waste, or the energy waste, because the AV controller was on at all times, and so it was always using energy. And this is a benefit of having a plug load study or a disaggregation study in your building to identify these areas of unnecessary energy use. All right, next slide. This is another way of looking at it. This slide shows the power consumption during occupied versus unoccupied times of the day. And so as you get further away from the 0 point, you get more more of that plug load is used during that time of the day. And if you look at the circle CMS TVs, CMS actually stands for Central Monitoring Station. So this is our security station. So this is showing that your security station is using a lot of energy at unoccupied times. And that makes sense because those TVs are on at all times, even when the building is, quote, unoccupied, but yet there's still security personnel on site because we're a national lab. But if you take a look at the one to the left of that, the AV controllers, those are on a lot during the unoccupied times, and the circle is big, so it is using a lot of energy. So we're not using the AV in the middle of the night. Nobody's in the building. We're not doing any conference calls or any presentations. So this is an area where we could potentially do a little bit better and find some energy savings. Next slide. And so from this disaggregation study, I have some best practices for the building owners. And one of them is use the information from the disaggregation to identify areas of energy waste. So that's like what we used with identifying some of the energy use from the AV controllers. The next one is continuously update and communicate plug load efficiency policies as devices and people change. So this basically means that, like, as commercial buildings, we've got different occupants coming in, new people coming in to work in the building or new people visiting the building, and there should be communication of the policies for plug loads. For example, in the building that we are working in, we're not allowed to have space heaters because they use a lot of energy. And so just making sure that those policies are reinforced. And the next one is energy managers should work with the AV team when they are upgrading the equipment. So this is a problem that I'm hearing anecdotally that's happening in a lot of buildings. It's that we want to have the best service for the occupants. Like, service is really important. So the AV managers have developing equipment that's always ready, always online. But what this means is that this equipment sometimes is using energy, such as in the middle of the night when nobody's in the building and nobody's using the AV equipment. So thinking of strategies as to how to make those AV technologies a little bit more efficient so that they're not on all the time, I think is worth investing in to look at developing strategies so that you're not always running those. And then finally, develop control strategies specific to the device. And so this again goes back to some things might need to be always online, like the security system, because security needs to always see what's going on the campus, but some things don't. So things like my computer doesn't need to be on all night if I'm not there. So develop your control strategies specific to the device. Next slide. This is my summary slide. So I talked about this because I wanted to present to those who are interested in lighting that there's a lot of reasons to be controlling plug loads, and you also want to consider the control of plug loads along with the control of your lighting system. So if we can integrate these two systems, this would be a big win, because with plug load controls, you'll get these additional energy savings. You'll also be able to understand the energy use in your devices, and then you'll understand your occupant behavior, what their needs are when they're using energy, and potentially tailor policies to help them. And then finally, this initial push for integration will also help with the interoperability efforts that are underway right now at the national labs. So I think the first step to this interoperability is integrating these end uses. So it's great that the ILC is focusing on integrating things like plug loads and HVAC with their lighting controls. Next slide. It's great being able to present. Thank you very much to Felipe and Michael again. This is my contact information. Feel free to send me an email. Either I or one of my team will get back to you if you have any questions. And then, like the other BBA teams, we have a website you can go to find some more information about plug loads and the resources that we have.
Thank you very much, Dr. Trenbath. Next slide. I'm going to pause also at this point. We have received a couple of questions, so those who have asked questions, thank you. There is my apologies, I should have mentioned it earlier. There is a question pane over in your navigation pane of the webinar app. So if you have either a question or a chat function you need, you can chat with us, or if you have any questions, as some of you have submitted, you can share them. So I'm going to present on a couple of some data that has been reported in reports, as well as some recent field work. The Department of Energy does have a number of ongoing field evaluations of specifically lighting integrated with both plug loads and HVAC systems. Unfortunately, a couple of the sites have closed down because of the pandemic. So our data is a little delayed, but we're getting it. Also, the usage data is a little different right now. So we're waiting to recover some of that data. So these are some of the modeled reports, as well as a recent field evaluation that are worth talking about. The first two are modeled, and I was trying to identify what's modeled versus what was measured in the field. And as Dr. Trenbath mentioned, if 40% of your building is plug and process load, and you're able to save 20–30% of it, that actually can save you a lot. So it's important to tackle that. So in the first two reports, you'll see that they were modeled. They were more, analyzing all the loads in the building and what the potential were. And if you applied the typical savings, they were saying about 23% of all devices, or about 30% savings. Those are two different reports, and I can provide you with references if need be. And it related to a significant savings. In some cases, it was about 50 kilowatt hours a year, or in one case, it was about 30 kilowatt hours a year. Those, as I mentioned, were both modeled. The third one is an actual field evaluation coming out of an Air Force base in Oklahoma. Again, it was field measured. They saved almost 40% of the controlled outlets, about 38% to be actual. But sadly, the actual energy savings only resulted to 2 kilowatt hours per year. So you can get significant energy savings, but if you don't actually focus on the loads and the right loads, you may not actually achieve your desired savings. Next slide, and I'll show a little more about that and reinforce some of the stuff Dr. Trenbath said as well. So what they did there was they used a manufacturer's product. As Dr. Trenbath mentioned, you can use the ox sensor in the light fixture, and what it did is it spoke to a wireless receptacle. They had to rewire the receptacles, so that is a little bit of cost share in that issue. Why this works compared to other strategies: there are smart plug strips and other plug devices you can put at your desk. However, if you get up and move, or they get pushed in the sensors get pushed in the wrong way, they may not be detecting when you actually truly are there, and you get a false signal telling the load to turn off. And we always want to try to avoid the false signals, because that's the quickest deterrent. People will just remove the equipment and negate all the savings as possible. It is a wireless sensor. I would tell you the one technical challenge they had on site was after getting the receptacles installed, they did have a small delay and had to do a firmware update. So one issue to think about is that when you move to a wireless solution, you do have to start dealing with some firmware, and that can be a small technical hurdle. It can be addressed, it can be managed well, but you need to pay attention to it. Also mentioned from the site, they did save about 38% of the savings of the control plugs, but it only resulted in a 2 kilowatt hours per year per receptacle. The key thing, and I highly reiterate what Dr. Trenbath said, was you need really an on-site advocate. These are automatic controls in that they will automatically turn off when the space is empty, and as we saw in some of those figures, some of those loads were significant in the middle of the night when there was no one there. So it's great that that can happen, but if you don't have a person on site advocating either what loads you can or cannot have, or designating what receptacles you plug devices in, you will not achieve some of those savings. That was actually one of the challenges with this Air Force base. They did not have an advocate who said, okay, this load is switchable and therefore it needs to go in the switch receptacle. They tried to give some guidance, but you really need a more active on-site person who helps reinforce it and reminds people. They did see some load shift in the middle of the summer. We don't think that was from an air conditioner. We were a little confused on why some of the load increased, but it underscores why you do need someone to support and champion this technology. We are seeing slightly better indication of switched receptacles. In this example, you'll see it in the center that it is indicating it is a switched receptacle with the circle with a line through it. We have seen manufacturers put tape on the receptacles to indicate when they're switched loads. I personally would like to see something at the end of the plug of whatever the device is that maybe next to the safety tag says ideal for switched loads. We do know that some loads are better than others, and yet if we are going to expect end users to know which one it is, we need to try to give them as much guidance as possible about which loads are better to be switched than not. And that's some area where I'd like to see some additional work and in communication if possible. Next slide, please. So we've mentioned that those integration with plug loads and all the reasons why, but with these occupancy sensors and light fixtures, you already have them. Why not do other things with them? And there's definitely been a lot more interest in integrating the occupancy sensors with the lighting with the HVAC systems. There have been a number of small simulated studies, one-off kind of field elaboration, depending on what the measure is and the building type. This table kind of sums up all the different savings that we've seen over a number of reports. Some about 17 to 20%, as high as almost 40%, depending on what exactly they did. And in one example, you'll see that I wrote 0%. And that's mainly because not every building can integrate the HVAC successfully. Next slide. So the idea with the integration is, again, you're reusing that occupancy sensor that you already have, probably for code reasons. It's sending a signal probably to the through BACnet to the building automation system. You can do temperature setback, you can do fan, you can do demand control ventilation. And those are all saving things when the space is empty. And it is achievable through standalone sensors. However, that's an additional cost. Batteries, those type of things that you have to think about. So it's easier to do through the lighting. And as I said, we're seeing a growing interest in it. However, your savings will vary by your mechanical system, as well as your building design. In the example that I showed earlier, why we only saw 0% savings, it was a multi-story high-rise where they didn't have thermal barriers separating some of the spaces. So one system was compensating while the other one was reduced and negating some of our savings. In retrospect, it's best to prioritize what type of spaces you have, and we are providing some of that guidance on the Integrated Lighting Campaign website. There's a guide that another Department of Energy program has developed that will be available to help explain it. And as I said, one of the other challenges is that energy savings are very hard to extrapolate. There's been a number of lighting savings out there that we do know what the savings look like. We are starting to get more savings in these other areas, but this is one because it involves both the cooling as well as the heating season and a number of variables at play. Your savings can vary, but Department of Energy is working on more data to help approximate those savings. I am conscious of time, so next slide, please. All right, non-energy benefits. So we are now moving beyond building integration to anything that why integrating your lighting system matters and what the advantage of it is related to anything that can help add value that is not what we consider an energy field. Next, please. So non-energy benefit is anything that you really can do with the lighting or lighting sensors as an asset to help do more functions in a building to increase operations. A great example is in healthcare. You can put a Bluetooth beacon on a cart and be able to find it faster. There's some data out there that says that nurses spend almost an hour a week looking for equipment just to use it. It's a way to help track it. Next, please. You can also do this in leisure through information in museums. You can use tags, again, through Bluetooth or a few other applications to use the lighting as an asset. It's sending a signal to either a headphone or in wayfinding mechanisms, and this is adding value. It's a way of integrating the lighting beyond just providing visual light. You are enhancing the space. Next, please. Offices, another key one that you might see is in space utilization. You're using the occupancy sensor not only to turn off the lighting when the space is empty, but that data with a great enough resolution can help tell you whether or not how many people are in your space or how often your space is being used, and you can use that for planning purposes. Next slide, please. Retail, we are seeing this through visual light communication, where they're able to use the light and you turn it on and off at such a high frequency that your eye cannot see, but you can actually send it through data to a phone or a mobile device, and you can help people find a product that way or deliver promotions through an opt-in advertisement. Again, this is how lighting is able to integrate in the space and add more than energy benefits. Next slide, please. Outdoor, we are definitely seeing a number of exterior lighting fixtures incorporate sensors as well, monitoring air quality, possible gunshot detection, or even vibration. They can hear how cars or trucks are driving down the road and use that sound change to actually provide information about whether or not a road needs updated maintenance. So these are all, again, things on how the lighting can be integrated into a space and add more benefits. Next slide. And finally, transportation, wayfinding is by far the easiest. We're definitely seeing this in a number of airports where through the app that you have with your airline, it's using, again, Bluetooth is used for a lot of these, but you can use Bluetooth in it, and that's how they help you find your gate faster or other means or possibly parking or even wheelchairs. So they're using the lighting as a beacon because it's everywhere, and they can help people triangulate and find things faster. So these are all the non-energy benefits. These are things that lighting can integrate into a space and add more benefit. Next slide. And why that matters, we're gonna next, one more. Okay, perfect. So the opportunities are tap into higher value proposition for energy savings. It is a small but measurable cost and can often exceed the energy savings. The challenge, limited information. We're desperately trying to get more information about what projects are out there that are doing this. We'd like to help evaluate if we can. Each building and business will benefit differently. So again, that's one of those things where we're trying to get more peer information, and what you can share with us is equally helpful. Next slide. So the Department of Energy is also starting in June this IoT-Upgradeable Lighting Challenge. The idea is that you can use standalone IoT sensors. So everything I mentioned that was a non-energy benefit is an IoT and Internet of Things application. You can do those through standalone sensors. So the problem is where are they mounted, how are they powered, does the mounting affect or limit your data acquisition? In the bottom, the example on the left is an office. They had to stick sensors for humidity and CO2 and moisture. There's about 200 of them. They put them under the desk. Yes, that's a fine application of it. However, you have to find a place to mount them. People can break them. People can steal them. Again, they have to be powered. So you have to constantly worry about having to change the batteries. Even if it's a 5 or 10 year thing, it's something you have to worry about. However, you can integrate your sensors in your fixtures. Why? One, many of the fixtures are already using some type of sensor, so you might be able to get dual purpose out of it. Two, the light fixture already has power. It also is physically there, so you can place the sensor in the light fixture. And three, the lighting is everywhere in the space, making it easier and a natural grid. Next slide, please. Currently, if you wanted to upgrade your lighting fixture, the option on the left is the current method. Staff would have to go get to the fixture, they'd have to remove the driver, they have to physically run wire from the driver and install the IoT sensor device. Possibly that device is bolted on and it may not be able to be changed in the future if you need a different IoT device, or they have to replace the fixture outright. All those are costly because labor is always a high cost. What we're proposing in this IoT Upgradable Challenge is a fixture is shipped with a certain type of driver. It's called D4i. It's a standard in the industry. They would also be shipped with and designed with a port that is standardized in a couple of different configurations already as part of the fixture. And then the fixture is installed now. And in a year, if you want to use an IoT application, you're able to, from below, install that sensor or IoT device, and your fixture is now powering it and operating it. Why a standardization is helpful is, let's say in 2 or 3 years, you want a different IoT sensor. Maybe someone comes up with a great app for social tracking, for physical distancing in a post-COVID world, but that sensor is different than what you currently have. Through a standardized platform, you can take it out and stick that new sensor in. So a standardization process is very helpful. Next slide, please. So as I've mentioned, the IoT Upgradable Lighting Challenge will be kicking off in June. It is similar but different from the integrated campaign that we've been mentioning. We're hoping to work with end users. This kind of outlines their process. The letters signal to manufacturers there's a market, reducing risk for product development, which helps manufacturers develop products. Products are also evaluated to confirm they meet performance requirements. and then ideally the products are on the market and become used on everyday projects. At this time, I'm going to turn the presentation back to Felipe Leon. Next slide, please.
Great. So we are getting close to here, wrapping up and having an interchange of ideas and contributions of some of your project experiences. And what we're going to ask now is that, you know, from what we talked about, that you join us for the ILC launch of the 2020 summit again, that you think about some of the integration projects that you've had experiences on. So we want to talk about those today, and also as we're going through the campaign, you can let us know about those also. But that's the idea of the exchange today. And then for the IoT-Enabled Challenge, if you're interested, as Michael said, you know, we're seeking letters from end users that are saying, hey, I'm interested in making sure that I have a future-proof building, and lighting is one of those things that I want to make sure it's future-proof because of those ideal situations of where it's located. It's got power. It's real simple to have a sensor go up in the sky. So next slide, please. So at this time, we'd like to open it up for the last 8 minutes or so for team discussion. I think that's always been one of the benefits of these calls, is that we get to have an exchange. And I put some of the topics that we've discussed today so that they can just help you remember some of the things that we covered and maybe some of the questions that you had for each of those particular sections. So I'm going to ask if we could just open up the microphones to everyone. If you could, when these are opened up, if you could just mute yourselves. If you have a question, but you'll at least be able to hop in and share. So thanks a lot to Michael Meyer for great presentations of some of the research that has been going on at the labs, and I look forward to hearing some of the input from other attendees. And hopefully the microphones are open now. And
a lot of people. If you
okay, thank you so much.
50-50 the whole fucking life. We'll change their silos.
All right. Thanks. I hear somebody on. Is there a question?
You get one day. And you just
Michael is really, in the past, has been one of the best at soliciting some input from attendees. So I'm going to try to give it a shot. Design Lives Consortium, I know, has been involved quite a bit. I know there's a couple of attendees from DLC. Just wondering if there were any from all the projects that you have been involved in and some of the research that I've seen. There have been some integration with HVAC. How have you seen that, DLC, in terms of the benefits and the interest around that from both the utility perspective as well as a building owner perspective?
Philippe, this is Doreen.
Yep.
Hi.
Hey, Doreen.
Hi, how are you? It's nice to see you. Good job to you and the team. I just have a few things to add. I don't know if I'm going to answer your question specifically, though, but we are indeed beginning to see more and more utilities begin to establish incentive program structures around integration, but it's not prolific at this point in time. It's kind of scattered here and there from what I've seen anyway. And we're also beginning to see, you know, beyond code incentives as well. I think those two work hand in hand. And so the incentive structures are quite varied, as you know. I really can't comment at the project level, but just to say that I think that there's an increased cognizance to the importance of integrating systems to help us reach our goals, which now are net zero and decarbonization of buildings. So hopefully within the next few years, we'll be getting to see more and more of that now that some programs are in place, and hopefully more to come. But that's what I have to offer. Sure.
Awesome.
I don't know if Levin or Stuart want to weigh in. I think they're on the call too.
Okay. Levin, you're welcome to chime in. I know we have some building owners too, or some that are supporting some of the building owners. We've got CBRE that was on. Kathy, if you're still on, have you had any opportunities to do integration projects in your buildings? Okay, maybe Kathy left, but how about looking at the non-energy benefits? We've in the past had some healthcare building owners call in or managers. Are there any healthcare sector attendees that are on? And can you talk maybe a little bit about the real-time location services if you're using that in your building and some of the benefits that you experienced? I also invite any retail or hospitality to chime in, which we have had in the past. Okay. So before we wrap up, though, there were a few questions that we did receive. So let's take a look at those. I think Kim, you might have had a couple questions on your section.
Yeah, sure. So I see that a couple questions. One is which load is going to grow faster, plug loads or process loads from today to 2049. Plug loads are the ones that are going to grow a little bit faster, or they're going to grow a lot faster, but they're a smaller percentage of the pie. So the plug loads are expected to grow, and then but both plug and process loads are expected to grow. Plug loads are going to be growing faster. And then the next question was, what are the small consumer devices in the breakdown, the disaggregated breakdown? And those include really small loads such as lamps, like LED lamps, and then also phone chargers. So small ones that are too small to kind of list separately in the disaggregated breakdown. I think those are my questions that I have.
Great. Thanks, Kim. All right. We are getting close to the end, and we have had a very shy audience this time around, a little bit different from our prior calls. So just one last minute, anyone that is willing to share before I adjourn the meeting? Okay, great. So I want to thank everyone that took the time to call in. You see our contact information here. If you have any feedback about any of the programs that you heard about today, I certainly would like to hear from you. Integrated Lighting Campaign at pnnl.gov if you would like to join the campaign. And these slides will be made available to you. Thank you so much for calling in, and I hope everyone has a great rest of the day and that you all stay healthy in light of our COVID-19 situation. So take care, everyone. Have a great day.